In this video, we're going to take a look at engine blocks, cylinder liner, how they're made, and how to service them. First off, um, engine blocks and how the manufacturer numbers the cylinders is dependent on how the manufacturer wants them. They could have, for instance, if you take a look at the left, the front of the engine could be number 1. There are some manufacturers that the front of the engine is number 6. So this is where we have to take a look at how the manufacturer sets it up. If we're taking a look at an 8-cylinder, we could have it going number 1 at the left front, number 2 at the right front, or we could have 1, 2, 3, 4 all the way down one side and 5, 6, 7, 8 down the other side. So really we have to take a look at the service manual to determine how the configuration of the engine is set up. Now, an engine's an engine's an engine. They all have basically the same components. It's just how do they configure these components? And we have to understand that for every engine, as long as we can understand how the components work, we should be able to troubleshoot it. So the basic engine has a cylinder block, and that's what we're going to discuss today, cylinder blocks and liners. We're going to go into crankshaft, camshafts, cylinder heads, pistons, and connecting rods later. So an engine block has some machine surfaces, and these machine surfaces have to be true, otherwise components won't align properly. And again, depending on the manufacturer, we may have a replaceable liner. So these are serviceable items. So we have an engine block that we can reuse, and then we can take some of these components out and replace them as they get worn. When we're taking a look at again, taking a look at the machine surfaces, so we have our front of our block, our head, or our top of our block, our rear structure, and our oil pan. All of these are machine surfaces that have to run true. And we're going to go in and how we're going to inspect these surfaces to make sure that they're serviceable and they don't have to go out to a machine shop to be resurfaced. So how a block is fabricated or made is usually, for the most part, is called what's a sand casting. And a sand casting is where they take silica sand and they'll pour molten metal inside of it to form the block. And then once that's completed, the sand will be removed and then the block will go to machine surface or to a machining shop to get to surface. Now, there are also some engine blocks that are two-piece, and they may have a cast upper section or a welded upper section and a welded lower section, and they're joined together. The bigger the engine, the harder it is to do the casting. There's also an engine called an end block, and this is where the cylinders are actually cast right into the engine block itself. Now, they could be cylinders that are made of a different material than the cast, and when they cast it, they're molded together. Because cast iron itself isn't very wearable. It tends to want to wear out. So they may make the liners out of a different type of material. There is a video on how engine blocks are made, so take a look at that. Now, if we have a two-piece engine block, for instance, they'll use this on a ship. This is a large engine. So they have the bed plate, which is attached to the bottom of the ship. Then we have the crankshaft, and then we have the upper block that's placed on this. And again, there are some videos on how these are put together. This is a ship engine, so it's a massive piece of equipment. So we just can't cast that in sand casting, so it's usually made in sections. This is a crankshaft for a large ship engine, and again, there's a big lathe that will turn this, and again, the tolerances are pretty tight. There are other manufacturers that will bolt Uh, Again, two 6-cylinder engines back to back to give us a 12-cylinder. And then there are some manufacturers that will manufacture a V16 all in one. So again, it's still an engine is an engine, but how we have to attach it and bolt it together and um, take a look at it is all the same for the engines. The other thing that we have is replaceable plugs in an engine. Now, these could be a threaded plug or they could be an expansion plug. Threaded plugs are usually oil galleries. Expansion plugs are usually coolant galleries. And this is, again, the engine has to be cooled properly. So these plugs have to be in there and they can't be leaking. If we're doing a complete rebuild on an engine, these expansion plugs and threaded plugs are usually pulled out so that when we go in and we clean the block, we can get any debris that's in any of the oil galleries and any of the expansion plugs if they're starting to fail or get thin, we can replace them at the time of the rebuild. You really don't want to have to rip an engine apart to replace these later. So once we have the engine block all stripped down, we're going to wash it and inspect for any defects. And then we're going to go through and how to check this engine to make sure that it is serviceable and the block is good. Steam cleaning or parts washer. So this will have a detergent in it that's going to wash all the oil and grease off of the block. Once that's done, don't let it sit there. It's got to come out and it's got to be uh, blown off with compressed air. And then the liners, if it is a dry liner, the liners have to be coated with oil so that they don't rust. So after it comes out of parts washer, it can go if you have a high temperature oven. And this will dry everything out and any components, it'll burn them off. Once we're finished with that, then we can go in and we can clean all the oil galleries out. So again, these plugs here have to be removed because in behind this plug, dirt can get there and we don't want that going through the system and getting caught in a bearing. So we use this special wire brush that goes in and cleans all the oil galleries out and then they're blown out with compressed air and or with solvent. When we're inspecting a block, and this is really critical to make sure that we don't have any cracks or problems when we are assembling the engine. So we don't want to wait till we're going to assemble it to find out we have a defect in the block is no good after we spent all this time. A couple of things we really got to watch for is the one on the left is debris that gets down in the bottom and we run a bolt in with an impact. It'll hydraulic that screw thread and can bust out the bottom of it. So we really using an impact to run these bolts in is not a good idea, especially if we have to oil the head bolts to put them in. If oil gets down in the bottom there and we run that bolt down, that oil has no place to go and it's going to bust out the bottom. And we wouldn't know until it was too late. The other thing we watch for is cracks from these bolt holes that go into the liner. Because if we have a wet liner, water can leak out of there and rust that bolt in place. And then they're really tough to get out. Now, there are certain types of thread inserts that we could use to repair damage. For instance, if we go back to the last picture, if we've got a crack in here, that can be drilled out and a threaded insert can be put in that's totally sealed. So at the bottom, it's water can't get into it. And then it's machined off at the top to make it nice and clean at the surface. These are a couple different types of thread inserts, even though they're not sealed at the bottom. So we run a tap in there, we run this in, and then these four little prongs are pushed down and it locks it in place so it can't come undone. Helicoils are another thing, for instance, front and rear covers is making sure that we don't run the bolts in with an impact because we can strip the aluminum covers out. So if it does happen, helicoils are our best option because they're quick and easy to put in and repair damaged covers. When we're inspecting the engine block, we have to check it for flatness. Now, again, because engine manufacturers vary whether it's a single cylinder head that goes on the block or whether we have 2 or 3 heads. But the cylinder block has to be level. If it's not, if it's warped or twisted, we've got to send it out and have it machined flat again. So what we're going to use is a straight edge with a feeler gauge, and we're going to check it in various locations across the block. So we want to check it in the middle from end to end, and we want to check it on the diagonals. So when we check it from end to end, we're checking for a bow or a sag in it, and when we're checking side to side, we're checking for any type of a twist in the block. Now, the other thing that they do is they can pressure test a cylinder block to check for cracks. And what they'll do is they'll block off all the ports. So the liners would be in there, all the coolant ports would be plugged off, and they pressurize it in water. So they put this in a big tank and they'll pressurize it. And the water has to be warm because again, as the metal heats up, it expands, and any cracks that are there will be more visible when the block is warm. If there's any cracks, it can be repaired, and we're going to talk about that near the end of the video. The other thing we want to do is we want to put all our main bearing caps in. So we're going to assemble the engine, and it's really important that we number our main bearing caps. Now, if you take an engine apart, it may already be numbered. So it's one of the first things we should check. Most main bearings are numbered on the camshaft side, but there's no guarantee that they are. So pay attention when you're pulling an engine apart, how they're numbered and where they're numbered. Are they numbered from the front to the back to the front, on the left side or the right side? And they all have to go back the same way. Always have a notepad by your toolbox when you're rebuilding an engine so you can write these things down, because who knows, maybe it might be a month before you get back at it. So we want to ensure that when we go to assemble that we're going to assemble it the right way. Otherwise, we're just going to end up with a failure. So once all the bearing caps are on and torqued to 3/4 of the torque, we're going to check the block. So what we're checking for here is where the crankshaft runs. And again, we're going to use a straight edge and a feeler gauge. And we're going to go along and we're going to check in a few places to make sure that the block is square there, because we don't want the crankshaft flexing, because eventually it will break. So again, across the bottom, one of the places we don't check is on what's called the parting line. The parting line is where the bearing cap and the block meet. So we can check anywhere else on there. We don't have to check the top, but we can check the bottom in a couple places. And if you notice on these bearing caps, they have an arrow and an F, which means front. So that's the front of the block. Another thing that we should be taking a look at is liners and or even the roundness of a main bearing. So we're going to use a dial bore gauge. Now a dial bore gauge is preset to a measurement. Let's just say our main bearings, and again, this is without the bearings inside the block, because when the manufacturer machines it, he will give you let's just say it's 3 inches in diameter, 3.000. So we're going to set the dial bore gauge to 3.000, and we're going to go in and we're going to check the bore in different places, again, not on the parting line. And what we're checking for, the dial bore gauge doesn't give us a reading, it gives us a plus and minus. So it might, let's just say it's 3.005, which means it's 5 thou bigger than what it should be. Now, there is a specification for every engine which they will allow a tolerance for, plus or minus, let's just say 2 thou. If it's over that, then it has to be remachined, because if it's too large, we run the risk of that bearing spinning inside there and taking out the crankshaft. So we take the dial bore gauge again. We check in different spots. We check in 3 spots, but 2 on each, because again, we want to check to see if it's ovaled or out of round or out of spec. We also want to make sure that it's not tapered. So as long as it was machined right, it should be even. And we want to do each one of these bores. Now again, when we take a look at this gauge here, you can see that these numbers. So they're usually in half thou increments. So the red would be 5 thou larger, the green would be 5 thou smaller. So we're going to use a dial bore gauge when we're checking our blocks. So again, don't take measurements on the parting line. So here we're going to take up and down. We're going to take at this angle and then at this angle. And we're going to record our measurements. So for each bearing bore, we're going to take 6 measurements, 3 on the front side, 3 on the back side. We're also going to do our camshaft. Now, because our camshaft doesn't have a bearing cap, we have to fit it inside. And here we're just going to take 2 measurements. And again, the bearing shells have to be out of here to take the proper measurement, because with them in there, that doesn't matter. We're going to do a different one with the bearings in. Now, if we have a crack in the block, it can be stitched. Now, there's, again, a couple videos I have that show how they can stitch a block. There is one that's called an overlapping stitch, where they drill, they tap, and they put a plug in. Then they drill and tap and put another plug in, and they just keep going along, and it seals the crack. The problem with this type is as it heats up, it can still expand. And there is another type that actually keeps the block joined together so it can't stretch. So watch that video. Now, if a block has to go out for machining, let's just say that the cylinder head had some surfaces that were starting to wear on there, they'll send it out to machine shop, and machine shop will put it on a milling machine, and it will mill the head, and they'll take off 5 or 10 thou depending on how bad it is. Now, there is a certain amount that we can take off and still use the original gasket. If more has to come off, we have to go with a thicker gasket for the machining. So there is a measurement that when we measure from the center of the crankshaft to the top of the cylinder head. Now, if that measurement is below specifications, that's when you're going to need to have a thicker head gasket on there. Again, now what happens if this bearing bore is out of specifications? So let's just say it's worn. So what they're going to do is they're going to take material off of each of these caps and then put the cap back on. And when they machine it, they will take material only out of this cap here. They're not going to take it out of the block, because if we go back and we take it out of the block, then it moves the crankshaft up. And we don't want to ever move the crankshaft up, because we run the risk of the pistons hitting the cylinder heads or the valves when they're open. So it's always taken off the cap. Crankshaft centerline, again, when we're taking a look at inspecting a cylinder block, where is the majority of the wear? Well, it occurs 90 degrees to the center line of the crankshaft. So when we take a look at the major thrust area and the minor thrust area, on the compressions or combustion pressure pushing down on the piston and how our crankshaft is aligned, it wants to force that piston over to the left-hand side. And because of the pressure in the cylinder, we call this the minor thrust area. Now, on the major thrust side, on the minor thrust side, it's when it's on its compression. So as it's pushing up, the connecting rod wants to push that piston over to the right-hand side. So we'll get most of our wear on the left-hand side, but we're still going to get wear on the right-hand side. So it's something to pay attention to when we're inspecting it. Now, if we have replaceable liners and we're doing a rebuild, we're going to be replacing the liners anyways. But there are also, again, when we took a look at that uniblock, where the liner is actually part of the block itself and it can't be um, replaced. We have to machine it out of there. So it goes to a machine shop and they bore it out, and they could put a sleeve in there, or we go to oversized pistons and rings. One of the things we should always pay attention to is the ridge that's at the very top of the cylinder. Now, the ridge um, is on a diesel engine isn't as bad as it is in a gas engine, and the most amount of wear is always just below the ridge, so you can see where the piston rings stop. So what we have is we have a cutter on this, and it goes along and it cuts this ridge out. And it's really important that if we're rebuilding an engine and reusing the block, that we take that ridge out, because if we put a new piston ring in there without cleaning that ridge out, as that piston comes up and hits that ridge, it's going to break the ring. And then we've just basically wrecked the rebuild. So we always want to remember to remove that ridge. And it's easier to get a piston out with that ridge removed than it is to try and force it out. So this can be done with the piston still in the engine. Then we want to go in and we want to use our dial bore gauge, and we want to measure how much taper we have in our liner. So we do this with the liners in the block. So we're going to measure at the top, the middle, and the bottom. Some manufacturers want 4 different measurements, and we're going to measure them 90 degrees to each other. So we're going to check for an oval, and we're going to check for a taper. And there is a specification. The taper for most engines is 5 thou. Anything more than that, and the engine could overheat, because the piston rings have to, as they come down, because the bottom has very little wear, they're going to compress at the bottom, and as they go up, they're going to expand and they're going to compress as they come down, which is going to generate heat. So we want to make sure that we're usually within 5 thou of our taper. So we're going to measure A and B on each of the cylinders. And again, we're going to measure the top, the middle, and the bottom. And we're going to write these down and compare them and check for our taper and our out of round. Now, let's just say we've had to send this block in to have it machined. There are some blocks that can be machined and have a piston that's 40 thou larger. And so there's also some other blocks where they can machine it out and put a sleeve in and go back to the original, or even go into a larger piston. So there's special tooling that the machine shop has for repairing cylinders. And then once everything's finished, they run a hone in. Now, anytime we're honing a cylinder, we should always be flushing that cylinder as we're honing it to wash away any of the debris. Otherwise, what will happen is our stones will get plugged up with the cast iron, and then they're not going to cut properly. And what we're after is we're after setting up a crosshatch inside that cylinder so that the oil has something to attach to, so that it helps lubricate as the piston's moving up and down. So the cross-hatching pattern should be between 40 and 60 degrees. Now you can do this with a manual hone or with a carbon hone, but always remember we got to flush these as we're doing it to make sure that the stones stay clear. So this is before the honing. You can see that it's glazed up, and then after the honing, where we got our crosshatch in there, and these scratches aren't very deep, this crosshatching. But it cleans the whole cylinder up. And as you notice, there's no ridge at the top anymore, so the pistons can come all the way up to where the ridge was. Anytime we're honing and we're doing an in-frame, we always have to protect the crankshaft. So if the crankshaft's still in the engine, we got to cover it up because we don't want any debris going into the oil galleries in the crankshaft. And then as soon as we start it up, that debris is going to come out and it's going to wipe out our brand new bearing. So always put a rag around them and tape them up if we're doing an in-frame. Again, two different types of hones that we might see. This is a carbon hone, it's just little carbon balls, and this has stones on it. And they come in different grits. There are some, again, engines that have, for instance, a Detroit two-stroke. The liners can come out and they can be replaced. So as we're doing a rebuild, the liners come out and then we inspect the block. And we're going to, if the block is good, we're going to install new liners. Now, an old Detroit two-stroke has really, they don't have a head gasket. What they have is they have O-rings that fit in these recesses. So you put the O-rings in there and then you drop the cylinder head on top of it, and that's what seals it. So there's ones for coolant and ones for oil, so that oil can get to the top of the cylinder head to lubricate the the rockers. So we got to make sure that each one of these that requires an O-ring is there. And if you're doing a V8, because the V8's on an angle, they've got to stay in those holes. So it's really important to make sure that if you're doing that, is that they're all on there before you put your cylinder head on. And they all stay in alignment as you're installing it. So we have a puller, and in some cases we can just use a slide hammer to pop these liners out. And in some cases we can't. We have to use a press, and it's got a puller on there with a hydraulic ram. Once the liners get in there and the O-rings swell a little bit, they're tough to get out. Now, two different types of liners that we might see. We've taken a look at a little bit of a wet liner, but this is what's called a dry liner. So the block is machined very accurately, and then this dry liner is fit inside of that bore. Now, it's really important when we're putting dry liners in that we follow the manufacturer's recommendations because they're very thin and they're cast iron. That where the liner fits inside, it has to be perfectly clean. Now, they're a nice tight fit, so we have to heat up the block a little bit and we can cool the liner. So heat gun, we don't want to use an open flame, but a heat gun up and down inside the bore will expand that. And if we put the liner in a freezer, we can shrink that and they'll slide right in. Now, depending on the manufacturer, most of these do not have a seal anywhere because we're not sealing everything or anything on this liner. This is another liner puller. So the shoe goes down inside, will hook onto the liner. Anytime you're pulling a liner, make sure you use the proper liner shoe because it has to fit inside that liner properly. If it's off to one side, we could actually damage a block if we're not careful. This is one that uses a hydraulic ram to pop the liner free. Once it's up a couple inches, usually the liner will pull out fairly easily. Again, making sure that once we get it all set up there and we just put a little bit of pressure on, we get underneath and make sure that that liner shoe is lined up properly on the liner itself. When we're doing dry liners, it's really, really important to make sure that that shoe is properly because how thin the liners are. Now, if for any reason we're, excuse me, any reason we're going to be reusing the liners, and in most cases we don't, but if we ever have to, we have to inspect those liners. And there's a bunch of things we want to check. We want to check for any cracks that are in the liner. We want to check for any scuffing marks. Remember the minor and the major? We want to check to see how bad those scuffs are. The other thing we want to take a look at is electrolysis, pitting of the metal. And what happens is the liner will, as it's going from the compression stroke, the liner will actually move over. And what we'll get is cavitation in the liner. And cavitation is caused by a vapor bubble. So as the liner moves over, a vapor bubble will form on the opposite side. And then when the liner moves back, and this is very minor movements, that vapor bubble will implode. If you remember from hydraulics when we talked about cavitation, what happens? And this is pitting from cavitation, and eventually that pit can go all the way into the inside of the liner. And what happens then is under compression, air can be forced out through this hole into the cooling system. One of the first indications that we have is a customer might say that it started overheating climbing a hill and then it progressively got worse and worse and worse. And that's an indication that we have a liner that might be cavitated. So a couple things we can do to check this out is take the cylinder head off, and we can look down inside and look for any rust marks. So rust marks on the inside, and it happens very quickly. I had a customer come in, and again, he started out overheating as he was climbing a hill, and it got so bad that it would start to overheat as he was bobtailing. So one of the first indications that we have this is, again, the overheating thing and pressurizing the cooling system. So what we can do is we can put a pressure gauge on the cooling system, and we're not going to pressure it up, but we're going to rev the engine up and let it come back. And we're going to do this a few times. And we're going to watch that pressure gauge to see if the pressure rises and falls. If it does, it's an indication that we might have a liner that's cavitated. Now, if we have one that's cavitated, chances are that if on a six cylinder, all of them are cavitated. And to go in there and just replace the one liner that we suspect is got cavitation and causing the problem, you got everything apart, it's best to check them all anyways. Again, it's up to the customer, and the customer I had only wanted to replace three. A couple weeks later, he was back and we had to do the other three. So it would have been cheaper to do all six of them while he was in there. The other thing we want to check is down at the very bottom. Now, at the very bottom of the liner, we usually have a crevice seal. They may call them different things, but it's at the very bottom of the liner. And as the liner moves up and down, and again, it's very minor as this thing moves, we're going to get some erosion happening. And this is where we can get coolant bypassing the crevice seal and leaking into the base. So we want to really make sure that if we're going to be reusing the liners, that we inspect the liners and make sure that they are reusable. At the very top of the liner, again, we want to check for any scale buildup, any erosion, any uneven wear, and we're going to be measuring all the liners and make sure that they still fall within the specs. So we're going to take our micrometer and we're going to measure in 4 different spots. Now, there will be a specification what we're allowed out of tolerance. Let's just say we're allowed to have 1 thou difference between those 4 spots. If we're over that, the liner has to be thrown away and a new one has to be put in. On the block itself, we also want to check for our counter bore, and this is where the liner sits inside this counter bore. Now, we also want to inspect the depth of this, but we want to check for any erosion that's in there. Again, this has to be even, because if the liner is even and it sits down and our counter bore isn't, the pressure can actually crack the top flange of a liner off. So we want to inspect that properly. So if we take a look at this last picture, if this is even and the block isn't, it will crack this flange. So we're going to take a depth mic, and again, we're going to measure in 4 different spots. And again, there will be a specification what we're allowed out of tolerance. And this is done again with the liners out. We can also use a sled gauge. So this has a dial indicator on it. We measure from the top surface of the deck down into the counterbore. Now, the other thing, once the liners are all put in and held down in place, we want to check what our liner protrusion is. And the liner protrusion is the difference in height between the deck of the block and the top of the liner, but not the fire ring. Now, the manufacturer may specify that you're allowed to have 1 to 3 thou, but no difference than 2 thou between each liner. So there will be a specification of what you're allowed to have for clearance. Now, if the liner protrusion is a negative number, which means that the liner is below the deck, there are some that will allow you to put shims in. The shims fit underneath the liner, between the liner and the block, which will raise the liner up to give you your proper liner protrusion. So these are the shims. So when you measure this and you measure this, you may have to add shims to get your liner protrusion to what the manufacturer recommends. Now, let's just say that this here is our counterbore. If we had corrosion in here or it wasn't right, we can go in and we can recut the counterbore. Now, when we recut the counterbore, again, we don't want a straight corner in the counterbore. We want a little bit of a curve here, and this is to prevent it from cracking. And in a case like this, we're going to have to add shims to bring that liner back up to specifications. So anytime we're measuring, we should be holding the liner down in its seated position. Now, when we're doing our testing, we don't have to put the seals on the liner itself. We can do it without the seals, get all our testing done, pull them, and make sure you mark them. As you can see here, there's a mark of where the liner goes in place. So if the liner's a little bit out, we can actually turn it and find out where it fits perfect, and then mark it so that when we go to reassemble it, it's marked and set back in the right position. When we're taking a look at, again, at a dry liner, so the difference between a wet liner and a dry liner is a dry liner doesn't have any coolant touching the liner. So it's like a automotive block, but we have a replaceable liner. And again, these liners are fairly thin and fragile. So when you pull it out, chances are you're going to wreck it, and they're not reusable. And again, when we put it back in, there won't be any coolant in there, but we're going to heat this up and drop this liner back into place and make sure it stays where it's supposed to. Now, there's no coolant in here, so it can't leak out the top. So in most cases, there's no seal on any of these dry liners. So wet liners come in a couple of different varieties. So again, on a wet liner, coolant's going to touch the liner itself. We have a crevice seal, and here they call it a lower seal ring bore, where we have seals that actually fit on the liner itself. And this will prevent coolant from going into the base. Now, anytime that we're replacing the liners, we should get the cylinder heads, everything put on, put coolant back in before we even put the oil pan on. We should heat the block up and pressure test the cooling system. And the reason for leaving the pan off is so that we can go and look underneath up. And what we're going to be checking is all the area around the block in here. And we're going to be checking for any leaks. So if we get an O-ring that's rolled, it's a place where it can leak. And if it leaks, then coolant's going to get in the base. So we have to pull everything apart. And it's better to do it now than it is to do it after the truck's been out and running, and we end up with a lot of coolant in the base. Now, why do we want to heat the block up? Well, to heat the block up is to allow it to expand. And when it expands, that's when the leaks are going to show up. When it's cold, it may not. So we should always be checking this with the block warmed up. Now, again, some of them may have a seal ring up on top, some of them may not. So on this one here, this is a Cummins, so they use 3 O-rings. They use a thick one and then 2 thin ones. Now, the O-rings can be on the block or they could be in the liner. So if you take a look here, the O-rings are in the block itself, and in this one here, they're on the liner. So it all depends on the manufacturer. Now, some manufacturers will color code their O-rings so that they go into a certain spot. So make sure that you follow what the manufacturer says and how they're set up. Some manufacturers will say to use engine oil on the O-rings. Some manufacturers will say to use vegetable oil. Let's just say we're supposed to use vegetable oil and we use engine oil, it could deteriorate that O-ring. The other thing is if we're using engine oil and we put it on the O-ring, it's maybe because they want that O-ring to swell. So don't put oil on the O-ring and go for coffee, because if that O-ring swells, you'll never get it in there without rolling it, and then you end up with a coolant leak and you wonder why. So always follow the manufacturer's recommendations on what they want to put on these seals and how they want them installed. Now this is called a mid-stop liner. So coolant doesn't go down very far. It's just at the very top. And again, this is where most of our heat is generated on combustion, is at the very top. So they'll have a seal ring here and a seal ring here. So again, coolant can't get down in the base, but it also can't get up onto the upper deck. If we have air-cooled cylinders, so again, totally different how they're set up, but they're still a cylinder. Instead of having coolant, now we have fins that radiate the heat out, and air passing by these fins is going to draw the heat away and keep that cylinder cool. Again, we inspect it the same way. We're going to inspect it for any cracks. Any debris that's in here we should clean out, because if there's debris in the fins, air can't help pull that heat away from that liner. Now, we talked about different types of testing. There's non-destructive testing. I'm not going to go through the videos, but there's 3 types, and so take a look at the types of testing. So there's a dye penetrant that we talked about in first year, where we're going to clean the component. We're going to spray it with a red colored dye. We're going to wipe it off. Then we're going to take and we're going to spray a developer on it. This developer, when it dries, is a white powder, and anytime there's a flaw, it will draw that red dye out, and you'll see a red line in the powder. This here uses a magnet, and they spray on this magnetic particle stuff, and it will show up under a black light. Ultrasonic testing is, again, they're going to use ultrasonic sound waves. So watch the 3 videos that I have posted on the 3 different types. And again, ultrasonic, they send a sound wave through a material, and the sound wave reflects back to the receiver. If there's a flaw or a crack in the material, you'll get 2 sound waves coming back.
To start the
so this video, this video here, watch this one. This is how they can stitch a block.
Spacing here about equal
and
to
so
1/2
it goes
of the
through,
lock.
if there's a crack in here, how they're going to do it. So watch this video also. And that's it for locks and liners.